Guys, so here we're going to take a cheeky little peek at how to derive / prove the old sine rule. So it's used in non-right angle triangles. It's in both of its forms down here at the bottom. They're both identical. You can get from one to the other by just flipping the fractions over. The form on the left is ideal for finding angles, and the one on the right is more useful to find side lengths. Doesn't matter which form you use at all. It just cuts down on the algebra a little bit if the guy you're looking for sits on top of a fraction. So let's have a cheeky little look at how to derive it. So the first thing we do is, out of the top angle, we draw a straight line down to the base of the triangle that sits perpendicular to the base where it meets it at right angles. The reason we do that is we've now split this up into two right angle triangles, and we can play normal SOHCAHTOA trig inside the triangle. So from the left hand side triangle we can get the sine of A is equal to H, which is opposite, divided by B, and then we can multiply by B, and that will tell us that B sine A is equal to H. So that's important. In the right hand triangle we can do exactly the same. We'll get sine B is equal to H over A, and then just as above we can multiply through by the A, and that will tell us that A sine B is equal to H. How is that useful to us? Well, we now know two equations for H in terms of A and B. So if both of those things here are equal to H, that means that they are equal to each other. So if we set A sine B equal to B sine A, all that we now need to do is either divide by the little case letters or divide by the signs. So I'm going to divide by the signs and get A over sine A is equal to B over sine B, as we were expecting. Now, how do we work out the C part? Well, let's have a little look. So we just draw a straight line out from either angle A or angle B, like this. So again, that it's perpendicular to the opposite side. And then very similar to before, the top left hand side triangle tells us that sine C is equal to, this time I've called the line G. So it's equal to G over B. So we get B sine C is equal to G. And then the right hand side triangle tells us that sine of B is equal to G is equal to G divided by C. So that tells us that C sine B is equal to G. So again, we've got these two equations for G this time. So they're both equal. So this tells us that B sine C is equal to C sine B. And then again, divide by the signs. We will get B divided by sine B is equal to C divided by sine C, as we wanted. So we know then from before that A over sine A is equal to B over sine B. Now we've just shown that B over sine B is equal to C over sine C. So all three things are equal. Job done. Cheers, guys.